Hello friends, welcome. Friends, today I teach Newton's first law of motion and Newton's second law of motion. So our first question, write and explain Newton's first law of motion. Friends, we know that Galileo gives the law of inertia. With the help of this law, Newton's find out law of motion. Means Galileo's law of inertia was basis of Newton's law of motion. Newton's first law of motion. Every body continue to be its state or rest or uniform motion in a straight line unless compelled by the some external force to act otherwise. A body at rest or motion of body moving with constant velocity both represent zero acceleration. Hence Newton's first law can be represented as follow. Force is physically quantity which can bring body at rest into motion and which can change velocity of object. In short, physically quantity which can produce acceleration in body is called force. And from Newton's first law, magnitude of force cannot be known. This is its limitation. Look here. Here some bags are at rest, but all these bags are motion with uniform velocity. This is a Isaac Newton and this is a Galileo scientist. According to Newton's first law, this is a football. We are not apply some external force, so it may be rest. And in universal, object is continuously moving. Means on both object, total force is zero. And acceleration also zero. Means look here, total force and acceleration in both cases are zero. Next question, when body is at rest or it is in uniform motion, no force act on it. When body is at rest or in uniform motion, gravitational force act on it. Force like friction force, viscous force act on the body. When object is at rest or in uniform motion, resultant force of viscous external force act on it is zero. Consider, look here, now we have one book on the table. Look here, this book. And on this book, two types of force are available. First, weight of body in downward direction, and second, normal force in upward direction. Here book is at the rest, hence its weight and normal force both are equal and both are in opposite direction. So total force on the book is 0. In fact, both force cancel out each other. Hence book is at rest. Actually, it should be like this. Considering book at rest by Newton's first law of motion, resultant of external force acting on body must be 0. This suggests that normal force and weight should be equal in opposite direction. Our next question is, momentum give more information than velocity alone. Friends, momentum means mass into velocity is equal to momentum. We understand with two examples. So example number first, if pebble and a stone are thrown with some velocity to hit a man, then it is very difficult to identify which cause more damage as the velocity of both. The object is same, velocity are same. So we can know the force on object by studying the change in momentum of the object. The velocity or mass individually are not enough to study the effect of body and another when they collide. By knowing the mass, we can say that momentum of stone is greater than pebble, hence stone is going to cause more damage. We know that all these are things. Second example, let us assume that a car and truck are stationary and horizontal road. Now we show video. Look here. One truck is moved any one direction. So it has some force. Look here. Here one car, its mass is m1 and truck mass is m2. All person are same and they are apply same force on car and truck. Means F1 is equal to F2. In total same time. Means T1 is equal to T2. But the mass of the car M1 is less than mass of the truck. Okay. So velocity of this car is V1 and velocity of truck is V2. So we can find out their momentum. Let us assume that car and truck are stationary or horizontal road. To bring them in motion to same velocity in equal time interval, car require less force and truck require more force. Also, if they are moving with the same velocity, to bring them to rest, car require less retardation force than to bring truck to rest in same time interval. Thus, to determine effect of force, momentum gives more information than velocity alone. Short question, what is linear momentum and write its SI unit. So look here, the definition of momentum is product of mass and velocity of body is called its linear momentum. So linear momentum, it is denoted by P. So P is equal to mass into velocity. Symbol of mass is m and velocity for v. So P is equal to mv. So momentum is a vector quantity and its direction is in the direction of the velocity. And the unit of SI unit of momentum is kg meter per second or Newton second. And in CGS unit of momentum is gram centimeter per second. Friends, in chapter 2, we learn dimension formula for momentum is m1 L1 t raised to minus 1. And next question, IMP question, write and explain Newton's second law of motion. First of all, its statement, time rate of change of momentum of a body is proportional to resultant force acting on it. This change is in direction of resultant force. Let's resultant force F act on body of mass m for delta t time interval. During this, let us its velocity change from v to v plus delta v. Means, first of all, now we want to find out its initial momentum. According to definition of momentum, we can write down Pi is equal to mv. And final momentum Pf is equal to m bracket v plus delta v. So change in momentum, it is denoted by delta p, means final momentum minus initial momentum. And instead Pf we can write its value mv plus delta v minus mv. Here m is multiplied inside, so we can write down mv plus m delta v minus mv. Here mv cut, so we get delta p is equal to m delta v. Where according to Newton's second law of motion, we can write down force is directly proportional to change in momentum. Means F is directly proportional to delta p upon delta t. Vector F is equal to, here now we take k. K is a constant of proportionality. So k delta p upon delta t. But right hand side now we take limit delta t tends to 0. Means F is equal to limit delta t tends to 0 k delta p upon delta t. So when now we take limit, so delta is converted into d. So we get F is equal to k dp upon dt. In this formula, we substitute F is equal to P is equal to mv, means F is equal to k d mv upon dt. According to u into v formula, first of all we m as it is, now we take derivative of v. In second term, v as it is and derivative, now we take mass. Means km is km dv upon dt plus kv dm upon dt. But friends, look here, with respect to time, mass is not changed. So this right hand term is constant and its value is 0. So we get km dv upon dt. According to definition of the acceleration, instead dv upon dt, we can write down a for acceleration. Means F is directly proportional to mass and acceleration. Thus, the force acting on a body is proportional to produce of mass and velocity. The value of K is obtained from definition unit of force. If 1 Newton force is required to produce acceleration of 1 meter per second square in 1 kg mass, then 1 is equal to K into 1 means K is equal to 1. So Newton's second law of motion gives magnitude of force which can be obtained by F is equal to ma equation. And SI unit of force is kg meter per second square, which is called Newton in SI system. And in CGS unit of force is gram per second square, which is called dyne. And friends, here definition of 1 Newton force and definition of 1 dyne force. You prepare it. It is very easy. So friends, today we discuss Newton's first law and second law. You write in your notebook and prepare it. Thank you.